Personal Finance Test number 12. This is again a two-part problem. Part 1, we'll go through the first two sentences, and then Part 2, we'll finish up. This is similar to problem 11. There's the compound interest formula, which we will need. We'll also use the sum of annuity due formula. The difference between them, recall, is that the compound interest formula, you're just watching what happens over time with one deposit. We did that with Sir Topham Hatt in the past problem. The sum of annuity due formula is how people normally save for retirement. Every year, they will put a little bit in their account. It's not a single deposit, it's repeated deposits of the same amount. Okay. Cindy saved for retirement for 12 years by depositing $1,050 each year into an account with 6% annual interest. Then she stopped making more deposits. So which of these are we using? Compound interest or sum of annuity due? Maybe pause, make a guess, figure it out, and then keep going. So it's sum of annuity due because she's making repeated deposits every year the same amount. And this formula looks longer, but it's nicer because all of that stuff we were doing with, well, how much exactly is the principal? And are we doing a divided by 12 or a 52 or some sort of garbage with how often payouts happen? None of that complexity happens with the sum of annuity due formula. We only use it for annual rates in numbers of years, so there's no fidgets. We can just start plugging things in. We don't need all the stuff we wrote in blue last time. So her principal is $1,050. This is final amount here, right? Times 1 plus the rate, 6% annual interest would be 1.06. Now, these brackets I do need, and if I was writing things by hand, then I would use big brackets instead of square brackets. But since I'm typing when I made this, I had to use square brackets. That's the convention. You alternate. If you have smooth brackets, curved brackets inside, then you go to square brackets outside. But we don't need these inside ones. With the 1 plus rate, it's just a 1.06. The curved ones we do need. I am still going to draw them as big to remind myself where they're coming from. They were these things. Okay, so what do we have? The 1 plus rate, 12 years, minus 1, divided by, there's no 1 plus, it's just a 0.06. That doesn't fit. I will just write 0.06. Okay, some calculators, you have to hit a key right here to kind of go down from exponent land. Other calculators, you can just put the minus 1, and it knows you're done with the exponent. Remember to put the parentheses in your calculator. You will get the wrong answer if you leave out these parentheses. Okay, type it all in. 1,050 times 1.06 times, open parentheses, 1.06 exponent 12. Come down from exponents if your calculator makes you do that. Minus 1, close parentheses, divided by 0.06. And we get $18,776.24. That's the end of part 1. The question doesn't ask us how much interest she earned, but let's do that. I am curious. So her deposits were 1,050 12 times for the 12 years. So 12,600. So that means everything else must have been interest. So take this number, subtract away that, we'll get what? $6,176.24. Not bad. Okay, that was all an aside. We don't really need that. Moving on to part 2. Then she stopped making more deposits. She's into the world of just watching her money grow. So is this going to be compound interest or sum of annuity due? Think about that. Pause. Resume once you know. Okay, that's compound interest. She's just watching what's happening. There's no longer the repeatedness that we need for the principal for sum of annuity due. So we're in compound interest formula now. So let's actually get rid of this so we don't confuse ourselves. And because we're doing compound interest, we need to be a little careful. Let me know what we're talking about. So I will list out those things. The principal, the rate per payout, and the number of payouts. So how much does she start with? It's what we had, $18,776.24. The rate per payout, well, it's 6% per year. The number of payouts, well, it's 38 years. How are we compounding things? The account grows at 6% annual interest for 38 years. It doesn't say. It doesn't have the phrase compounded weekly, or compounded monthly, or compounded annually. When it doesn't tell you, by default, then we're compounding annually. And you only have two. I think it's just one. Pardon my spelling if I did that. That looks wrong. That's better. Okay. So we don't have to do anything. There's no divided by 12 times 12. There's no divided by 52 times 52. We're just done. Everything is years. We are good. So we plug things in. Remember that the compound interest formula has a 1 plus the interest rate. We are just putting the 1 in front, just like we did twice in the previous formula. We don't need those parentheses. We can just stick a 1 in front of a 0.06 quite easily. Okay, moment of truth. What does she have? $171,882.44. Is that enough to retire on? You'll have to read the other parts of the lecture to find out what a reasonable goal for retirement savings actually is. But that's our answer to this problem.